Good day, ladies and gentlemen. Welcome to Math 30-2, Chapter 2 Review. Now, at a private school, each student must wear a school uniform that includes a dress shirt and pants. The dress shirt can be white, gray, or light blue. The pants can be navy or black. Use a graphic organizer to show the different possible variations of the uniform. Now, graphic organizer is like some sort of diagram. So, number for the shirt, your choice of white, gray, or light blue. So two choices there. And for each pair of pants, you have two choices, navy or black. Navy, black, navy, or black. Now notice, that gives us 6 choices. And this is the fundamental counting principle here. 3 types of shirts, 2 types of pants, that gives us 6 choices. But here we're using a graphic organizer or a tree to show that. I can make you list them. It's just another way to list it. Now, so far so good? Good. So, a manufacturer uses a 6-character serial number for a line of products. The first and second characters are uppercase letters A to Z. That's 26 choices. The third, fourth, and fifth characters are digits 0 to 9. And there are only 3 choices for the last position, A, B, and X. So the question is, how many different numbers are possible if repetition of characters is allowed? So here, the first 2 digits, 26 letters and 26 letters. Then we have, let's go here, the first and second uppercase letters. The characters are digits 0 to 9. 0 to 9 means there's 10 choices, 10 choices, 10 choices. And then the last one, 3 choices, A, B, and X. 3. So, grab Mr. Calculator, 26 times 26, 10 times 10 times 10 times 3. 2,020,000. That's what I got. Now, did I make a boo-boo? Maybe, but check my math. Okay? So, repetition is allowed. That's how many serial numbers you can make. How many different serial numbers are possible if no repetition is allowed? Well, no repetition. The first digit is a number, a letter, A to Z, 26 choices. We've used one, so the next one is down to 25. Then we have 3 numbers, 0 to 9, so we have 10 choices for the first. We've used a digit, we're down to 9. We've used 2 digits, we're down to 8. And then we have, oh, poopy, spit that one out. My bad. The most important restriction is the last one, A, B, or X. We have 3 choices for the letter at the end, which means we've used a letter, so we're down to 25 for the first and 24 for the second. I keep this getting old. Anyway, so that is 1,296,000. Okay, so Mr. Calculator. Now, if you want to get picky, sorry, I'm going to stop for a moment, make sure you've got that. Once again, I apologize for the boo-boo. Anyway, I want to point out here, if you want to get picky, that's 25p2 times 10p3 times 3p1. If you want to do it that way, but I think that's more work than it's worth. Okay? So, how many different ways are there to draw one card that is a spade or a diamond from a standard deck of 52 cards? Here, number of ways it's spade or diamond is, since there's no overlap, or these are mutually exclusive, that is, you can be a spade or a diamond, but you can't be both. So that's number of spades, that's number of diamonds, that's 13, 13, which is 26. Okay. Next question. Simplify each expression, state the restrictions on the variable. Now, I really didn't talk about restrictions in class, but I will here. So look at this n plus 10 times n plus 9 factorial. I want you to realize, oh, that's just n plus 10 factorial. Now, the second one is a little more confusing, but we've done that in class repeatedly. N minus 2 factorial divided by n factorial. Which is bigger? Well, n factorial on the bottom. So, n 1 minus 2 factorial. And here we go, oh, I'm sorry, got the brackets at the top. And then, oh, we can cancel out n minus 2. This becomes 1 over n times n plus 1. Once again, in chapter 4, I'll show you how to solve this. For the moment, I just expect you to be able to FOIL it and multiply it out. N squared minus n. And stop there. Okay? So remember to show work with these questions. And as ever, if I'm going to move to class, pause the recording, think about it, or go back and watch it again. So, number 5. A parking lot attendant has 5 cars to park. 1 blue, 1 white, 1 red, and 2 black. How many different ways can the 5 cars be parked side by side? 1, 2, 3, 4, 5. 5 choices for the first, 4, 3, 2, 1. 5 factorial. But I have 2 black cars, 2 identical black cars, which means I divide by 2 factorial. And 5 factorial divided by 2 factorial. 5 now. 2 now. 60. 60. Okay? So far so good? Now, so that is just all 5 cars. And look at the other question. How many different ways can the cars be parked so the 2 black cars are next to each other? Sneaky, different question. Let me show you. Somewhere in there, we have 2 black cars parked together. Now we've got 2 choices for that. 2 choices for the first black car, 1 choice for the second black car. How many other cars are left? Well, 1, careful. We treat the 2 black cars as 1 big car put together. So this becomes 4 factorial times 2 factorial divided by 3 is 2 factorial. Yes, and that just becomes 4 factorial, which is 4. So be careful of that. Note the wording. In B, the black cars are next to each other, and in A, they're just parked somewhere. Notice different answers. And once again, I'm going to harp on about how the math isn't difficult, but you've got to be careful reading it. Okay? Which is why we're doing a bunch of examples here. Now, a book club, number 6, sorry, a book club offers a selection of 4 books from a list of 9 different titles. How many different 4-book selections can you make? Well, here, I want to stress, I think this is a combination. Order is not important. Which tells me we have 9 books. We choose 3. 9 NCR 3 equals 84. Oh, sorry, 9C. Sorry, 4 books, not 3. Yes, I can tell you're mad at me. It's not doing English today. Anyway. Now the advantage, remember using these fancy graphic calculators, Well, if you hit enter, you can fix your mistake without typing in the whole thing yet. 126. There we go. All right. So far, so good. Now, how many different four-book selections can be made if the four selections are listed in order of preference? So there's a restriction here, order of preference. That means permutation. As I said in class, if I've got 8 calculus books and a graphic comic there, what are you going to read first? The graphic comic. Yes, because nobody wants to read calculus. So this is 9, P4. Order is important. So we're doing math. 9, math, NPR, 4 equals, wow, 2024. A lot more options there. Okay. Now, the last question of this first part. Why are the answers to part A and B different? Well, as I said, A, combination. This order is not important. So you have fewer choices. As I said, for the combination, reading book 1, book 2, book 3 is the same as reading book 3, book 2, then book 1, or reading book 2, 3, yeah. So you get a lot of combinations are the same because order doesn't matter. Remember my pepperoni and mushroom pizza? Do you really have to lay the pepperoni first and then the mushrooms, or do you have to lay the mushrooms and then the pepperoni? As long as you bury it under a pound of cheese, it doesn't matter. On the other hand, P is permutation. Order matters. So 1, 2, 3 is not the same as 3, 2, 1. So you got many more, with permutation, you got many more options. Right? Now, I'm going to pause it there. If you have any problems with this, watch the video again, or shoot me an email. Otherwise, go on to the next video.